our bagler starts to feel angry and embarrassed that he was shown up by you and the bird in front of the king. And so he storms out of the room, and then a few seconds later he storms back in. He says, "My fault, my apologies. I realize now what the mistake was. There was a slight, I guess, typing error or writing error. In the first week when they went to the market and bought 2 pounds of apples and 1 pound of bananas, it wasn't a $3 cost. It was a $5 cost. It was a $5 cost. Now, surely, considering how smart you and this bird seem to be, you surely could figure out what is the per pound cost of apples and what is the per pound cost of bananas. So you think for a little bit, how is there now going to be a solution? So let's break it down using the exact same variables. You say, well, if A is the cost of apples per pound and B is the cost of bananas, this first constraint tells us that 2 pounds of apples, so 2 pounds of apples are going to cost 2A, because it's $8 per pound, and 1 pound of bananas is going to cost B dollars, because it's 1 pound times B dollars per pound, is now going to cost $5. Is now going to cost $5. This is the corrected number. And we saw from the last scenario, this information hasn't changed. 6 pounds of apples is going to cost 6A, 6 pounds times $8 per pound. And 3 pounds of bananas is going to cost 3B, 3 pounds times B dollars per pound. The total cost of the apples and bananas in this trip we are given is $15, So once again, you say, well, let me try to solve this maybe through elimination. And once again, you say, well, let me cancel out the A's. I have 2A here, I have 6A here. If I multiply the 2A here by -3, then this will become a -6A, and it might be able to cancel out with all of this business. So you do that. You multiply this entire equation. You can't just multiply one term. You have to multiply the entire equation times -3 if you want the equation to still hold. And so we're multiplying by -3. So 2A times -3 is -6A. B times -3 is -3B. And then 5 times -3 is -15. And now something fishy starts to look like it's about to happen. Because when you add the left-hand side of this blue equation, or this purplish equation, to the green one, you get 0. All of these things right over here just cancel out. And on the right-hand side, 15 minus 15, that is also equal to 0. And you get 0 equals 0, which seems a little bit better than the last time you worked through it. Last time we got 0 equals 6. But 0 equals 0 doesn't really tell you anything about the x's and y's. This is true. This is absolutely true that 0 does definitely equal 0. But it doesn't tell you any information about x and y. And so then the bird whispers in the king's ear, and then the king says, well, the bird says you should graph it to figure out what's actually going on. And so you've learned that listening to the bird actually makes a lot of sense. So you try to graph these two constraints. So let's do it the same way. We'll have a b-axis. We'll have a b-axis. That's our b-axis. And we will have our a-axis. And let me mark off some markers here. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So this first equation right over here, if we subtract 2a from both sides, I'm just going to put it into slope-intercept form, you get b is equal to -2a plus 5. All I did is subtract 2a from both sides. And if we were to graph that, our b-intercept, when a is equal to 0, b is equal to 5. So that's right over here. And our slope is -2. Every time you add 1 to a, so if a goes from 0 to 1, b is going to go down by 2. So go down by 2, go down by 2. So this first white equation looks like this. If we graph the solution set, these are all of the prices for bananas and apples that meet this constraint. Now let's graph this second equation. If we subtract 6a from both sides, we get 3b is equal to -6a plus 15. And now we could divide both sides by 3. Divide everything by 3. We are left with b is equal to negative 2a plus 5. Well, this is interesting. This looks very similar, or it looks exactly the same. Our b-intercept is 5, and our slope is negative 2a. So this is essentially the same line. So these are essentially the same constraints. And so you start to look at it a little bit confused, and you say, okay, I see why we got 0 equals 0. There's actually an infinite number of solutions. You pick any x, and then the corresponding y for each of these could be a solution for either of these things. So there's an infinite number of solutions. And then but you start to wonder, why is this happening? And so the bird whispers again into the king's ear, and the king says, well, the bird says this is because he, in both trips to the market, the same ratio of apples and bananas was bought. In the green trip versus the white trip, bought 3 times as many apples, bought 3 times as many bananas, and you had 3 times the cost. So in any situation, for any prices of per pound prices of apples and bananas, if you buy exactly 3 times the number of apples, 3 times the number of bananas, and have 3 times the cost, that could be true for any prices. And so this is actually, it's consistent. This, we can't say that our Begla is lying to us, but it's not giving us enough information. This is what we call, this is a consistent system. It's consistent information here. So let me write this down. This is consistent. This is consistent, and it is consistent. 0 equals 0. There's no shadiness going on here, but it's not enough information. This system of equations is dependent. It is dependent, and you have an infinite number. You have an infinite number of solutions. Any point on this line represents a solution. So you tell our Begla, well, if you really want us to figure this out, you need to give us more information, and preferably by a different ratio of apples to bananas.